Hello, grade 3, and good morning. This is Miss Susan. Today we will learn relate shapes, fractions, and area. Lesson 12.9. We will learn how to divide any shape into equal parts to create fractions and how we write this fraction in what form. And I said dividing any shape into equal parts, I mean here to divide it into equal areas. So that will be the relation between shapes, dividing the shapes to create fractions, and to cut any shape into equal parts or equal areas. So let's see how we can do that and what fraction will we create. So first, you can use what you know about combining and separating plane shapes to explore the relation between fractions and area. So first, for example, I have this shape. This shape has 6 sides, so this shape is called hexagon. First, he wants me to divide the hexagon into 2 parts with equal area. So I have to divide it equally into 2 equal parts. And how I knew that we divide it into equal parts, if I folded the separated parts over each others, it will be exactly match. So let's see how we divide this shape, the hexagon shape, into 2 equal parts. We can divide from this diagonal, from this vertex to this vertex, so it will create 2 equal parts. Also, I can cut it from this diagonal, from this vertex into this vertex to create 2 equal parts. Also, we can make a line from this vertex to the opposite vertex to create 2 equal parts. So you can choose any 2 opposite vertices to make a line between them. That's a straight line. Okay, so now I cut the hexagon here into 2 equal parts. If I fold it to the 2 parts over each others, it will match exactly. So this means the 2 areas are similar, or the 2 shapes are exactly similar, means it has the same area. So now, what the name of each shape separately? This shape is called, if you will say trapezoid, so you are right. Why? Because trapezoid has 1 pair of parallel sides, so it's called. So this is called a trapezoid. Write the fraction that names each part of the whole you divide. So each part here, if I imagine that I have each part separately, like this part, so each part is only 1 part, 1 colored part. Out. How many parts in all? So how we write the fraction? Do you remember? We said how many colored parts over how many parts in all for this shape. We cut it into 2 parts in all, right? In this code, each part of this divided shape is equal half. So each part is half of the whole shape, and that's right. Now write the fraction that names the whole area. And we said the whole area mean if I colored the 2 parts here, so that now is the whole area. So now name how many colored parts. 2 colored parts over how many parts in all. We divided the shape into 2 parts in all, and this means the whole number or the whole fraction or the whole shape or the whole area, anything. So if I see the numerator is the same number as the denominator, this means this is a whole area or the whole shape is colored, or a whole number. Okay, Explain how you know the two shapes have the same area. I said if you fold them together, it will give you, they will match exactly. So, fold. Okay. Predict what would happen if you divide the hexagon into three shapes with equal areas. What fraction names the area of each part of the divided hexagon? What fraction names the whole part? So again, if I divide into three equal areas, this means each part, this means each part will be one colored part over how many parts in all? In all, I divide it into three in all. And what is the whole area? The whole area, you want me to find the whole area. If I made the whole area, this means I will color the whole three parts, right? So three parts are colored. The whole parts in all will be three. So if I say the whole shape, the whole number, the whole area, this means that the numerator should be the same as the denominator. And I have the denominator is 3 because I cut the shape into 3 parts, so I have to put 3 up and 3 down. Show how you can divide the hexagon into 4 shapes with equal area. So first, I will make a diagonal line exactly from the upper vertex to the lower vertex. Sorry, the line is not appropriate one. Okay, so this one is right one. Now let's make another division. So this part I should divide it into 2 equal parts. So if I divide it from here, will it be 2 equal parts? No. If I divide it here, it will be 2 equal parts. Also no. So in this case, I will divide it from the middle. Okay, so now I divided the hexagon into 4 equal parts. So in this case, each part, what's the fraction of each part? So if I imagine that I colored one part here, so this means how many colored parts? One part over how many parts in all? In all, we have 1, 2, 3, 4 parts in all because we cut the shape into 4 equal areas. Now he wants me to find the area, and if the area are similar by counting the square net. So the rectangle at the right is divided into 4 parts with equal area. Write the unit fraction that names each part of the divided whole. Okay, so in this shape he has a rectangle and he divided into 4 equal areas. But can you see the shapes? Are they similar? No, over there still fractions. Why? Because they have the same equal area. So let's count and see if they have the same area or not. They are not similar shapes, but they have the same area. Can I consider them as fractions? Yes, I can, because they have the most important thing, that to cut the shape into equal areas. So in this case, I have 4 areas here. So this means I cut the shape into 4 equal parts or 4 equal areas. So the whole number in all will be 4. So the fraction here for each part is equal what? for each part separately will be 1/4. So every area here is equal the fourth of the whole area. Okay, what is the area of each part? What is the area? I counted each part. It gave me 5 squares. How many fourth parts does it take to make one whole? So one whole mean how many parts in all? 4 parts in all. So I need 4 of the 1/4 to make a complete shape. Is the shape of each of 1/4 part the same? No, they are not the same. They are totally different. The shape are different, however the areas are the same. Is the area of each fourth part the same? Yes, the same, all equal. Divide this shape into equal parts. Draw a line to divide the rectangle below into 6 parts with equal areas. So let's see how we can do that. Okay, let's divide it into 6 equal parts. So this is the first. From the middle we make a line. Then let's make a horizontal line here. A horizontal line here. So how many parts in all now? 1, 2, 3, 4, 5, 6. So that's the best solution. Now write the fraction that names each part of the divided whole. So again, the fraction is equal. How many colored parts? Have 1. We can imagine each part is colored like this shape. So 1, each part is equal 1, divided by how many parts in all? It's 6. So write the area of each part. So let's count each part equals how many squares? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So each area is equal 4 square unit. Each part is of the whole shape. So each part is 1/4, right? The fraction 1/6, sorry. So each area is equal 1/6. Divide the trapezoid into 3 parts with equal areas. Write the name of the new shapes, then write the fraction that name the area of each part. The best solution for this is to cut it into 3 equal triangles. So this one to the middle here, and a line to the middle here. This will create 3 equal triangles. So each part here create the shape of triangle. And the fraction here, and we said the fraction is how many colored parts? So each part alone, I imagine that I will color only one part here. So each part alone is 1 over how many parts in all? We have 3 parts in all. So each part partially is equal 1/3, because it is 1 part only over the how many parts in all? We have 3 parts in all.